could collect more information and record it and display it better. Okay. Hey guys, I'm going to put the battery on.
He's putting the battery on.
Battery coming on.
Battery coming on.
So this is the regular Dynon that you see, a D10, Dynon 10. We kept some steam gauges there because if we have an electrical failure, you still need this information. Right. The compass, of course, is our only navigation except for, oops, you'll notice that there's a place there for a Garmin.
Here?
Yeah, that we clamp in when we take this cross country. Now we used to do that quite frequently, but we have decided that the new bird is the cross country bird. This is going to be stuck here. We'll just do runway hops here. And this, what you see is all the gauges and all the information that used to be displayed on these gauges. Now some of these are still active, even though it's redundant, all right? But we use that primarily. Now this is just saying that the battery is on, right? So that's not really a caution light, though these blinking lights do suggest caution because there are low oil pressure alarms and things like that because it's not running.
Right.
That the Dynon picks up.
Oh, it's incredibly scary. I've done lots of scary
So anyway, we have our radio and our intercom, which are marginal at best because the wind noise against the microphone is so bad that we can't talk over there. If we take it cross country, or when we took it cross country, we actually have muff mics. That is to say, it looks like one of these headsets,
right?
But it fits over your mouth like this, so you can talk without the wind noise. Typical circuit breakers. We do have a strobe light. We have a device by which we can fill our header tank from the wing tanks, and then we have a primer in emergency. So if the engine-driven fuel pump were to fail,
right,
or before the engine starts turning, we need fuel for prime. It's an injected engine. So we'll just bump that. And that was the trouble starting this morning. We have been having difficulty because you don't know whether you have flooded it or it's starved for fuel. Right? Those are the two conditions that will prevent you from
same
starting,
symptom.
and they exactly the same symptoms. So what we'll do is we'll prime, try it, prime, try it, and if at the second time we've done that, we'll go ahead and just flood it, and then we know where we are, and we do a flooded start, which is with the mixture control full out and the throttle full in, and then at some point the flood will turn into the right mixture and it'll light up.
And it hits, when it crosses that threshold, you can start.
It'll start right away.
That's interesting.
A traditional key, traditional ignition. It is, in fact, I've got one thing that's unique, and that's something that the Wright brothers actually had too. Listen. It's an Uga horn. Now, they had it because when they came down to land in a field, it could be full of cows. Now, cows didn't understand airplanes, but they understood cars, right? They got bumped out of the way by a car. So that's an Uga horn, just like at the same period of time, the cars. And so they heard that, and they would scurry away, and then you could land.
And that's at Huffman Field. In other words, when they were landing in Huffman Field?
Yeah, well, it could be Huffman, it could be somewhere else. It depends on when you ran out of gas.
Now, I believe that both the steering wheel, and then you also talked about the auto steering, that these are new, right? These were not in the original Wright.
Correct. To explain that, the Wright brothers patent actually dealt with the flight control system, not the airplane. They used wing warping. They developed that as a method of controlling roll and patented it. That made the airplane controllable. So what happened is with wing warping, at very low speeds, you don't have enough energy in the air to correct for an upset. Now, we can't have wing warping because we need to safely land every time. And with wing warping, as you slow down, you make the correct control input, but nothing happens. And you'll drag a wingtip and crash, or something bad happens. So there were competitors at the time, to include Glenn Curtis, Now, Glenn Curtiss wanted to go to Europe at the same time or just after the Wrights did, but he knew he couldn't do the same thing they were doing for controlling roll because they were successful in suing everyone in the world. They had patented it not only here but other places. And they were successful in court at suing and collecting from those who infringed. He didn't want to do that, but he did want to fly. So instead of wing warping, he put a stub wing at the wingtip. That last panel that you see, that last two upright structures,
Yes.
those two bars, he put a third wing in there on the trailing side of the airplane. And he used the controls, the sticks that they had, to make that go up and down. When he went to Europe, the French saw it and said, that's not very eloquent. You could have just cut the panels out of the wings that existed. And of course you can. Now, that was the aileron and the invention of the aileron. I know it's a long story, but I'm getting to the end. Your question is nearing this answer. There were others who saw it and said, yep, because when all the bees were crashing, all the wing warping airplanes were crashing because of lack of ability to control in slow speeds, they all went to ailerons because they knew that was still capable of controlling the airplane even at low air speeds. All right, there was a guy named Burgess in Maine who had bought the rights to build an airplane like the Wright brothers had, and he developed these. This is exactly the kind of wheel he used and exactly the mechanism that he used, and he's built a kit so all those bees that were still flying bought the kit so they could fly safely. All right, so this wheel,
More or less, what was the year on that?
by 1918, everybody had converted. So it would probably been about 15 or so when he started his work on how to make a kit to put ailerons on the flying Wright Bs and his Burgess F.
And the control of the aileron was through this wheel,
Yes.
right? Was this a precursor or a follower of the car steering wheel? Which came
The car steering wheel came first by many years.
first?
Of course.
So that he borrowed from Otto in
He-
this
he-
case.
The parts were readily available. He just bought a wheel, some bicycle chain, and rerouted the cables. And I'll show you where
Burgess,
Burgess.
using Burgess did it, and then the Wright brothers basically.
They all of their airplanes by then they had already sold the company. You'll remember from history that Wilbur had been traveling the world and
Right.
he came down with disease, typhus or typhoid. I'm sorry, I don't remember which, and died early. Wilbur had been taking care of the factory and the production of these airplanes. When Wilbur died, they completed each other. They were paired for life, kind of. And he just lost interest completely. He sold out to a consortium of New York bankers at the request of the War Department, who recognized that they got caught short. I mean, at the beginning of World War I, you recognized that the airplanes from France and Germany and England were fast, they were nimble, they were robust, and we're not. We're none of those. Even though this was developed first,
Right.
they surged ahead. Well, in one reason, because the brothers split up, one taking the legal route, the other manning the factory, and they never got together again to develop something new. But that's how the wheel is. Now, we chose to put the wheel on because it is a safe way. We also chose not to use wood as they did. Ash and spruce were their choices. You cannot inspect inside of a piece of wood. Orville, you'll remember, crashed at Fort Myer, okay, and was almost killed. Selfridge, who was his observer pilot from the Army, was killed. And it was because of the wood that was used for the propeller came apart. The propeller, of course, cut structure and controls, and down they came. That's the problem with wood. So we are using aluminum and steel. By comparison, their bee weighed a little over 800 pounds. This one weighs about 3,200 pounds. Wow, what a difference.
Have we covered all of the significant differences in terms of the structure, the steering? the electronics, the navigational instrument, the
All of this is necessitated by
flight controls.
today's
Anything
rules.
else here that is significantly different from
Yes,
the Wright B?
the engine you'll recognize as a modern aircraft engine. It's the Lycoming HIO 390. You don't see much of it because it's in a shroud. The reason it's shrouded is the engine is actually turned backwards to how its normal mounting
Right, because it's pusher.
is pushing
Right.
instead of pulling. And what happens is we have a fan. The reason it's an H, helicopter version, is that fan is a ducted fan. It pulls all the cooling air in from behind, pushes it over the cylinders and out the bottom. That's the only way we could get enough cooling air that the engine would not overheat, is to use those shrouds and the fan. We'll look at that when we
Okay.
go back around there. There's a lot of other very subtle things that you may or may not notice, like the attachment of the tensioning wires is external, and they are thick. The Wrights had used thinner wires, and they were attached inside, so they're not quite as draggy. The blinkers that you spoke of earlier,
Are these fabric? No, these are metal. Okay.
the leading edge is metal. The rest of it is fabric.
It is.
Okay.
Okay.
Now you may be right over the
I think I am.
tapping on the fuel tank, because that's the inboard setting. As best we could, we replicated the Wright's design. We wanted to remain faithful. We call this a look-alike, not a replica. Replica suggests the same materials built the same way, and we couldn't do that and continue to fly safely. So, even though it was cosmetic, we put the blinkers on. That's those things right up front there. And they did that because they were weather vaning, as we were out there. That big slab tail back there, you get a side wind and it pushes the airplane around like a weather vane. Their idea was, if I put those up there, it'll be equally resistance. And even though it's the same area, it's called a moment. All right, the distance between the center of gravity and those, and the center of gravity and that tail, is so much different. Think of a teeter-totter in the playground, where you sit on one side and your 11-year-old sits on the other, and if you adjust the fulcrum point just right, you can balance each other. Well, that's moment, and they hadn't figured that out yet. So they put those on, and actually we know that it's destabilizing. We didn't get enough of a bank today. I kept this pretty level, but if you bank the airplane, those actually produce lift. So you bank
because
the airplane,
they're,
and then the nose starts coming up, right? So it's destabilizing in flight. We know that. They hadn't figured that out yet. You'll notice the wings have no dihedral. Dihedral is where the center to connect with the fuselage is lower than the wingtips. That way, if you get a slight upset, this wing is going to produce more lift than this one, and it will self-right.
right.
These do not. So you're flying the airplane 100% of the time. Don't know if you noticed, but even though we had some wind today, I was really active on the controls to keep us.
I did notice
level
that, but I assumed it was because we were getting buffeted by wind.
Some of that certainly was. But even in a very calm day, we still have to do that, because we have such a light wing loading. Even a breath of air on one wing and not the other will upset it, and you have to get ahead. The airplane has a personality. Well, no, it's got an attitude is what it's got. And if you're not paying attention to it, it gets really jealous. So, every moment you have to be flying the airplane.
I have two more questions for you. One is, so I'm actually working on a story just by coincidence about the importance of keeping historic aircraft flying, not just in museums. Why do you feel, as someone who flies one of the most historic airplanes, why do you feel it's important to actually see it in flight?
Actually seeing it in flight is not as important as feeling the flight. Okay. The experience that you got in flying the airplane is probably 90% of what the Wrights felt when they flew this same airplane, the Wright B. Okay. And I believe that's the important part. It needs to be preserved so that future generations will know the pioneer activities of the creators of this kinds of airplane. Now, in the panels that you see in front
And what do
of
they
you,
do with that? But what do they do with that? Once they have that, what do they do with it?
okay, most people, when they fly, think in terms of boarding passes and airliners, and when is, you know, am I going to have a comfortable seat? Am I going to get a soft drink? You know, those are the. You don't think about safety at all. Well, because they're very safe. You don't think about the inconvenience of the weather at all. The pilots are capable. The airplane is capable. If you don't know your routes, if you don't realize the fundamentals of flight, then at some point in the generations that follow, you lose the whole concept of where flight began and how important it was to solve those problems.
Okay, that's good. Now my second question was, so and when I sit in this plane, I'm not just seeing or experiencing the Wright brothers, but also sort of the modern engineering of, I don't know how much of a role you played, but obviously somebody put their own engineering ideas into this aircraft. So it's in a way, it's kind of a hybrid, isn't it? It's a modern and an ancient.
It is. It is, and that does create some problems. Our goal is to create an airplane that looks like the Wright B Flyer at 100 yards. Close up, you can see 1,000 differences, and we've talked about some of them. There are others, but what we wanted to do was to replicate as faithfully as possible the airplane that they built and sold to the Signal Corps. Army Signal Corps is the purchaser of the airplane. And we could have easily made several design changes which would have made it structurally better, aerodynamically better, but we chose to do it their way. I'll point one out to you that you can probably see from here. If you notice the chain on this side, they had counter-rotating propellers.
Mm-hmm. Right.
The chain on this side actually crosses over itself. The chain on that side runs true. It does not cross over itself. Therefore, the propellers are going to rotate in opposite directions. They did that because if both propellers were turning in the same direction, we know from their notes that they had trouble going straight. You have only so much rudder authority, and the propellers create more lift on the downward turning prop and so you get a turning moment. They couldn't handle that, so they thought about it and did that switch, and so we did too. Now we could easily have reversed the direction because we have a gearbox. We could have reversed the direction in there, but we didn't. We wanted to make sure that we replicated. I've already talked about the blinkers. There's another example. There's a whole bunch more examples where we thought it through and said, okay, we could have done it this way, but we won't. We'll do it the way they did, so that when we go on display and at air shows, we'll do a flight, and then we'll go onto display, and that's where thousands, literally, of people will be seeing the airplane that day, and we wanted to make sure that it looked like the Wright B.
Right. But my question is really like, what's it like to be kind of the guy, or guys, gals, whatever, who tinker with the Wright brothers' invention?
I got it. I understand. It goes back to the beginning. And again, there's no quick answer to this. So here goes. In the very first one, this one, that was built, there were no drawings, there were no specifications, because they were stored in the shed where the Wright brothers lived, which was involved in a flood. They lost all that material. They didn't bother replicating it because by that time they had moved on to other designs, other airplanes. And again, they never got together, so they never improved and worked forward. So what we did is we went to, there is a Wright B, an original that has been restored correctly in the Air Force Museum here. There's also one in the Franklin Institute and one at the Smithsonian. So we went over here and started doing measuring, and all the measurements were then taken by a high school drafting class and were converted from just dimensions into drawings. And we got a real thick drawing package, we still have. And then from that, we started building this. Now, saying we, I was not affiliated with the program at that time. It actually started in the mid-70s. And it was 82 when this airplane first flew. So it gives you an idea. It takes a while to build. And from those dimensions and from the pictures and from the drawings that we had, they built this airplane. And it's a progression. It took so long to build because you start running the cables and you realize, oh, we can't run them that way because it goes right through a bulkhead or something. Well, we're going to have to offset them. We're going to have to do this. So it was a whole series, as the Wrights did, of trial and error to get to the airplane that would fly. Now, there have been upgrades and changes to this airplane, all right, from its original status. Originally, the engine was not powerful enough, so they put a turbocharger on it. That was an addition. The Wrights didn't have turbochargers, all right. But again, the weight difference there is why we needed more power than they did. So from the drawings, the airplane was built. The airplane was built in a tinkerer's fashion because you needed to make corrections that weren't obvious when the drawings weren't clear. That took a while. And now the people who did that, however, were very professional. This airplane was built at what is known as the Modification Center at Wright Pat. At the day's end, a lot of the mechanics, the same people who worked on the modifications for modern airplanes, worked on this airplane on their own time, after hours, but the Air Force was kind enough to let us use their machinery, the heavy machinery that could bend and drill and do things like that. Its first flight was at Wright Pat, all right. Subsequently, the Air Force and the DoD and others changed. We couldn't even begin to do that today. But back in that time, it was a different world.
Is it a little intimidating to be, I know that perhaps you weren't involved in it, but do you think it would be intimidating to be the persons who modified the Wright brothers' creation?
Not necessarily. Remember the premise. We want to look as alike as we can and be safe. Now, this is our new airplane over here, and it's being built right now. In fact, we have been 4 years in building it, and we'll be flying it soon. We've run across the same situation there because, again, we've changed some things that make it different enough from this that we couldn't use the original drawings. So we took another set of drawings, again, looking at the original, saying, well, we want it to look like that. But you'll notice that the chord, the width of the wing, is somewhat shorter on that airplane, and also it sits lower.
Much lower.
Yes. Well, that's more accurate than this.
Uh-huh.
And when we get out, I'll show you why. When we flared at the end there, if we didn't have this height, then we would have dragged the tail.
Right.
To prevent that from happening, and again, as an example of how you make modifications, is that boom, you'll notice, is up about 3 degrees.
Yes. Uh-huh.
And what you cannot see, unless you have exceptionally good eyes, is that the chord line of the wings is up 2 degrees. So that means when we flare to land, we'll still have enough clearance that we won't bump the tail. But you see, we picked up 5 degrees of angle of attack over there that we would have used and put us in danger of bumping the tail on this one. So having had this one and learning from it, now, with regard to making changes, we have in our organization volunteers who have incredible credentials. For example, the chief engineer on this project formerly was the chief engineer at Wright Pat for all of Wright Pat. His background was testing at Edwards, and then came here and worked his way up through engineering and was the chief engineer at Wright Pat. And he can call on some of his buds if we have an aerodynamic issue, for example, if we wanted to predict what's going to happen, or a structures person. He still has reach back to the people who designed, built Air Force airplanes. We have to have them think slower, though, because all of their thinking is in terms of, well, how can I go faster, and how can I get more controllability? How can I pull 9 Gs or something like that? no, don't think that way. Okay, so they had to rethink for what we want, which is a 1G airplane at 50 miles an hour. And they can do it. But they're the ones that actually put the structure design together and some of that sort of stuff.
Okay, well, show me the